Claude can now build a whole app without ever running out of context. How? So every month we are doing a little call internally that discusses new things, new movements in the AI space. We'd love to do it more, but if you do it more often, you also risk shiny object syndrome, right? Or keep it once a month. And last week we've discussed sub-agent revamp, especially fork agents and units. So actually, as you probably know, when the context window fills up within a Claude Code session, so I'll just give dumber that how big doesn't necessarily say that you should always run on a lean context, but it's just good practice because there's what's called context rot, which I have a separate video about. That fall more expensive, and it's also there's the issue of AI not paying attention to whatever came in the middle of the conversation because it just pays attention to the beginning. And yeah, the issue is that your session dumber. Sub-agents before would be contextless, which essentially means they would get no previous context to them, which made them only so useful for things that were easily explained with just an input state, a small, prompt input and a task, and then a clear find deliverable. And so, each sub-agent had no knowledge about the previous context. And this is now changed with fork sub-agents that basically get all the previous context, and they can use that in order to make better decisions. So this is essentially, for example, they used to always have the BTW, which is a read-only version of this, but now these can actually also act. And how you enable them is just through fork, and that's whatever you want. Quite simple and convenient. But teammates, which are persistent sub-agents. Another thing that changed is that you can have sub-agents or sub-agents up to 5 levels D, which can get crazy if you, don't watch out. But ultimately, it means that the delegator can continue to delegate while keeping the main context fully. Essentially, oftentimes you'll run into the following situation where Claude will finish a task and it will say, hey, we've done everything, but here's 4, small things I would implement called mids. And so, what you can do is now, without, doing, okay, let's fix them all, which then inserts all the back and forth into the main context window. We will just fork them out and we say, okay, fork, let's do this task, let's do nitpick 1, fork, let's do nitpick 2, fork, let's do nitpick 3. And the main task, and you can continue working on it, which is one advantage, but also keeps the window lean. And so we never polluted with that work. And I think that is an advantage, and it gets you much further, retaining one window up to like whatever 200K context size where it still works really well, and you never pollute it with any of the side tasks. There's some issues with this. So sometimes if you fork a task, it doesn't notice this, so then it will start working on the same thing, and then you'll end up having conflicts between the forked agent and the main agent. So you have to say, I dispatch these 3 sub-agents, make sure not to touch their work, right? It's a little bit annoying. Hopefully they'll fix that, but ultimately it's better than having a bunch of merge conflicts or other issues that are worse. This isn't necessarily related to fork agents, but it's just a thing with agents where if you have explore agents, they often use Haiku. Just make sure to use Opus if you can, or at least Sonnet. But yeah, it's essentially because they just give back a deliverable. These explore agents that's clearly defined as like a summary of the findings or whatever, which, if you know the mental model, the map is not the territory, can lead to issues because the main agent will rely on it and it might not be 100% accurate. We could keep the critical path lean, and we can create a file for it, which will then become a scratchpad. This just for more, another learning where you want to continue trying to keep the context very lean, but you essentially need to still keep track of it. And then ultimately, what we get out of that is that we get, better decisions, longer autonomous runs, cheaper tokens, less babysitting. So this is just the payoff of keeping your main context really lean, whilst you will be able to get further, spending less money because more less tokens, which ultimately is money, right? And because each individual sub-agent just gets a smaller task of those fork agents, it will be more likely to be correct rather than have the main agent do 4 tasks in a row, which then again, piles up a bunch of context, makes it more expensive, but then also it's just less reliable. So yeah, if you are doing loops like what we're supposed to do now, right, this is obviously very helpful. And it is just kind of how to make your loops more likely to be successful if you keep to this split and you keep the main context window clean, because ultimately the loop will run within the main context and then delegate to the fork agents, slicing features into smaller tasks. And with a loop, ultimately it's all about the input and guardrails in order to make it running as autonomously as possible for the longest time possible. So smaller tasks are better because you will have less drift. All right. If any of that stuff sounds interesting to you, feel free to subscribe below, and I'll see you next time.